Polysaurus says cat cam, cat cam. It's true. The boy's hanging out with us today. One sec, let me get the music up. Okay, test, 1, 2. I think my levels are good. So here, let me just see if the game builds right now, and then I can walk through what I've been doing. So basically, lately what I've been doing is building all these different sort of level design and layout tools. First it was, here I can open up the main city gym and show you. First it was this building generator, right? So you can see, I've still got like a little bit of work that I want to do on it to create a little more variety between the buildings, but for now this is pretty good. There's 200 buildings that are like pretty easy for me to sort of control a bunch of parameters to create like variations for them, and they also make really nice geometry. I also built this like road tool, which you can see if I like move the intersection junctions around, is like live updating all of those roads. And then what I started working on next was, so I had just hand modeled this little tunnel down here, but then I go to my tunnel test scene, I actually made a specific system here, right? You know, I can move this around, and you can see this like lets me make sort of procedural tunnels that have kind of like, oh, this is a little dark on the screen, isn't it? And maybe I can go to omlit mode. Oh, that's even worse. But maybe detail lighting. There we go. So you can see I can like make tunnels. I can sort of yank these junctions around to change the shape of the tunnels. I can have intersections like with the roads. So you know, here I've made like a kind of tunnel with 3 entrances. I think I've also got another tunnel out here just floating in the sky in my test, which you can see I was experimenting with like how good it is at generating loops and having like different sort of shapes for the like cross section, and then having like tight corners and like really loose corners. And I think if I turn over here, there's some like elevation changes, so there's like sloped floors and things. And then so yeah, I like also built them so they had the ability to use, it's called constructive solid geometry, where there's like the ability to like add or subtract one mesh from another. So these tunnels are actually subtracted from this terrain mesh, so that, you know, you can, there's like a hole here at the tunnel entrance. You can see if I like yank this over, right, and then I like poke my train here, you know, it moves that hole over so that the hole matches over here. And I think I actually also need to just like, yeah, wobble that to get the road to go in through there correctly. But, so, you can see now I've got like a kind of like rotated, I guess, entrance to this tunnel, which might be interesting in different situations. So, that was kind of like me putting a capper on the sort of tunnel tool. There's a little bit more that I want to do with the cross sections. Like right now you can see I can like adjust the size of like the gutter. I can also make the gutter 0, and then this is just has like a rectangular cross section, which like looks a little more plain Jane when you're inside of here, but like might also be interesting in certain cases. So the next thing that I want to do is like these islands, like I just hand authored these in Blender, but like I don't actually. Polysaur says the pilot looks a little bit like Noah Izumi, your character of inspirational. You mean like from Pet Labor? Definitely. Like she's definitely kind of like spunky 80s like anime heroine, kind of like a kind of a mix of Noah and like Miyono Zaki from Tank Police and like Kay from The Dirty Pair, I guess. I'm just like doing all my favorite characters. But yeah, 100%, you're spot on. So anyway, if I go over to my train test scene, I've started working on this sort of thing where I just have like a spline, you can see here, and then I can select the points of the spline and I can move them around so that I can like quickly change up like how I want the shape of the island to be without having to swap between two programs. And then like ideally, like once I have everything blocked out and nice, I could like export everything, bring it into Blender, and then do all the detailing in Blender without having to make like big shape changes. But the way I set up this version, I'm kind of just taking this shape and then inflating it, which is like a little bit of a problem because you can see if I make like concave shapes, it's actually like not producing that nice slope over here. Also, if we look at this in this view where I can see the UVs that like Geometry Script has generated, they're like not very stable. Like if I'm just like dragging this around, they change quite a lot, and the ones around the sides aren't that great. The texture that you're seeing on this is just my like UV test texture. So like basically what I'm doing right now is I popped over into code, and I'm actually just based on like the input shape, just like explicitly plotting the vertices by like actually insetting insetting this polygon so that it will definitely slope no matter which shape you make, and also like very carefully generating the UVs so that it generates like a texture map that is like actually workable for when I'm actually doing material work. So yeah, that's the state of things right now. I'd hoped to be doing a little more sort of like compelling level design work today because I think that makes for a better broadcast, but I got sick yesterday. So I was like in bed with a migraine all day and didn't really prepare anything for today, so I'm gonna cut the mic and like basically just get back into coding. I'll like make some comments about what's going on in the code, but like yeah, if anybody has any questions about the game or whatever, just feel free to chime in the chat. This one's just gonna be like a chill hangout stream. So cool. Let me see. I wonder, is there a way to? Yeah, here I'm gonna do this. I'm gonna edit the title so people who come in late know what's going on. Coding, procedural, geometry, parentheses, AMA. Cool. So you can see the main function that I started here is called plot island. This is going to, we're going to take a 2D shape, and then it's going to like a plot an island out of that shape. And so you pass in like a U dynamic mesh. This is Unreal's like object that's like a working mesh that you can modify in place and then spit out static meshes from. And then I'm saying like every island has a height, which is how tall the sides of it is. They have an offset, which is sort of like how much to sort of flare out the bottom, right? So if you take the height over the offset, that's going to be the slope, right? So if these are, I'm defaulting these to 5 meters each, so that'll basically just be, 5 over 5 is 1, or like a 45-degree slope by default. You can change it. Then I have just this extra, like, island opts. Opts is my, like, abbreviation of, like, options. Let's get the board thing. There you go, buddy. And you're turning away from the camera. You're not voguing today, buddy. So, like, yeah, you can see right now it's basically just some options for where to place the UVs in the UV map. I'll probably add more options as I go, as there are a bunch of like little detail-y things. But my idea with these option structures, these are like advanced options that you're probably 99% of the time not going to want to touch, or if you're touching them, you're only touching 1 or 2 of them. So I didn't want to have like a million sort of methods on this function. Oh, the boy has left us. Okay, well, there goes the cat king. Here, I'll move this. Ooh. Now it's the max cam. So yeah, oh, don't worry, he'll be back. It's probably just like using the litter box or something. Anyway, let's get this. Roll up. Beep, 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 beep. Over here, over here. There we go. Does that seem good? Okay. Let's make my hair have a cool bangs. Great. So anyway, I started writing this function earlier. I'm like maybe about a quarter of the way through it, but you can see I do some early out checks first to say like, hey, if there's less than 3 corners in this shape, that's not a real shape. There's nothing I can do with that, so I'll early out. Also, if the height is 0 or the offset is 0, that's probably like not what we meant to do, so I'll early out before doing that. Then you can see I make a shape for the base, which uses this inflate points function that I had written earlier. Which basically takes a shape and like offsets all of its sides and then does new intersections to figure out where all the new corners are. And I also find the min and max like rectangle of the shape, which I use to generate the UVs on the top. Then for my working mesh, like basically inside this U dynamic mesh object, there's an object called an F dynamic mesh 3, which is the actual like container for the data. And so basically what I'm doing is I'm like just making one of those like on the function stack, which is my like working mesh. I go through and I fill that with all the geometry that I want, and then we call this edit mesh function on the like in-game mesh, which like as far as I understand this, like I think this is just calls this code directly, but like basically internally I get the actual mesh that I want to write my result to, and then I call this like special append mesh function, and what that's going to do is just like take my working mesh and like append it into this existing mesh, so I can actually append multiple islands into like one mesh. What I actually plan to do is have islands stacked on top of each other that I'm then going to do a union operation on, and that way I can have like height elevations like within an island, like you have kind of like a plateau inside of the island. So yeah, so without further ado, let me take a little drink here. Great. So you can see what I've already done is I've gone through and I've plotted the positions, right? So I plot all the corners of the shape on the top. I plot all the corners of the shape on the bottom. Here, I can draw this just to sort of like make this a little more obvious. Oop. So basically what we've got is like, yep, shrink down. There we go. Basically there will be some shape, right, that I want to like make an island out of, and then what I do is like I expand that shape out in all directions to make what's called the base shape, right? And then I project this down, right? Boop, boop, boop. And that produces like this kind of like bottom shape, or the base shape as I call it. And then my plan is to sort of connect up all these vertices, right? You can see this one is like sort of inside the shape, so I'll make it kind of hashed, like a dashed line. So yeah, so on this like plot positions loop here, all I'm doing is I like go around and I plot this position, this position, this position. Then I go through the base shape, I plot this position, this position, this position. Then I plot UVs. These are basically like the texture coordinates. One thing to sort of point out about this dynamic mesh 3 object is that it doesn't have to be one. So like they have like your vertices, which have a position. But then like in particular, like if you look at, you know, like this vertex right here, it has both like split normals, right? Like on the top, its normal is pointing up, but on the side, right, its normal is pointed slanted. Also, there's a UV seam, right? Like the texture map has different UVs going this way versus going this way. So rather than saying there's like one UV coordinate and one normal per vertex, they instead have these things called attribute overlays, and you can like basically plot like separate arrays of all the UVs and all the normals. And then when we plot the triangles, we're basically going to say for each triangle which vertices do I want and which UVs and which normals do I want. And they're not necessarily going to be at the same index, right? And that's useful so that it knows, like, for instance, when it generates collision for this, that like this vertex right here is a single vertex, even though on the GPU it's probably going to be split into 3 vertices for like this back facing side, this front facing side, and this top side. So it's just sort of like, you know, dealing with the fact that like this is more like a CAD representation where like there's one logical vertex here, even though on the GPU there's going to be 3 different vertices for the 3 different faces. This overlay, right, is kind of how they represent that. So you can see I plotted the positions for the top and bottom, and then for the bevel, right, basically I went around and I was like, yeah, this basically should be like one texture map, and this should be one texture map, and this should be one texture map. And then I also, so the next thing I need to do is to triangulate and plot the top. So like the top isn't necessarily a triangle, it could be like a concave shape, which means that we actually need to take this shape and we need to break it into triangles. And that's not like obvious, right? Like, cause like if I tried to break that into a triangle, well, this line is like outside of the shape. There's a math theorem called the ear cutting theorem, which means that there will exist some triangulation, and there's actually the ear cutting algorithm, which is basically like pick a vertex and like keep going around until you find like a cut that you can make from that vertex that like is totally inside the shape. That doesn't always lead to the best results. So there's a better one, which I won't like explain it because it's a little too complicated. It's called the Delaunay triangulation. For the purpose of the Unreal Engine, all you need to know is that Unreal has a function called the Delaunay triangulation that computes it for you. So that is what we are going to do next. But I think the first thing we want to do is plot the UVs for the, let's see, how did this work? when I plotted them for the bevels, I went from bevel menu to bevel max U. Okay. Oh, here I plotted the UVs for the top already. I just went through all the positions on the top, and I normalized them to the max to min range, and then I lerped from like the max U and the min to max V to get the actual like texture UV positions for the top. So yeah, now let's triangulate the top. I had written a function earlier where I did this, yeah, triangulation. So let me catch that here. So triangulate simple polygon. This takes an array of vector 2's, and then it tells you all the triangles. So now I should have this array of triangles. Here's what to say. Plot top faces. Plot side faces. So we can say for each triangle in triangles, we want working mesh dot append triangle. This one's going to take a group ID. I normally am not going to want to change the group ID, but just in case, I'll add it as like an optional option. And then what happens is when you append a triangle, you get an ID for it, you know, TID, triangle ID. And then you can use that triangle ID to assign UVs to it. So when we plotted the UVs for the top, all those UVs were just 1-to-1 with the shape UVs. So I should be able to say like UV overlay set triangle TID. It should just be 1-to-1, so I should be able to set the same triangle indices. And by the way, I would like also here be like appending the normals to this, except I actually just have a function to calculate the normals based on the faces. Makes writing this whole function easier, as long as you know it's like a faceted mesh where there's no soft transitions, it's all going to be hard transitions, then I can just use this calc normals method instead of having to figure that out. So I'm not thinking about normals in this function. I did have to think about it when I was doing like tunnels, but keeping it simple here. So now when I plot the side faces, let's think about this. When I plotted the positions, I plotted all the top positions, and then I plotted all the base positions. So if we go back to our illustration, that means that like, if I like grab pink here, this is like vertex 0, this is like vertex 1, this is vertex 2, and then this is vertex, like if there's n vertices, like this one n is equal to 3, but in this one n is equal to 1, 2, 3, 4, 5, right? This is going to be n plus 0, n plus 1, n plus 2, right? So when we're plotting the triangles here, right, like here if we look at it, imagine it from the side where this is like x plus 1, and then this is n plus x, and this is n plus x plus 1. Basically, we want like right hand rule, we want them to wind around our right thumb. which is weird because Unreal is usually left-handed, but in this one case they choose to be right-handed. So that means that, like, thinking about it, we want the triangles to wind this way and this way. So for each side, right, we want it to be like from this to this to this, and then from this to this to this, right? So we want to go through each side. So it equals 0, it is less than n is the number of sides, plus it. It is just my, like, shorthand for iteration, right? Like, the iteration starts at 0, it ends at n. This is a loop. So now let's see. We know that the first vertex is just going to be, yeah, let's just list them all out. The first vertex, we're going to call this V00, V10, V01, and V11. So V00 is equal to it. The V10 is equal to it plus 1, but we actually want it to be mod n. This makes it wrap around. So instead of counting up to n, we go like 0, 1, 2, 3, 4, and then instead of saying 5, we just wrap back to 0. That indicates, you know, that, like, this is the shape that wraps, you know, around, right? So we're going to go from 0 to 1, from 1 to 2, and then from 2 to 0. Then we have int v01, which was it plus n, right? So that gets us from this vertex to this vertex. And then similar int v11, we want to have it, or this was n plus it. Then this is going to be n plus it plus 1 mod n, because that one wraps around too. So then the two triangles that we want to add to 0 is working mesh append vertex, and it's not append vertex, append triangle. So that triangle f index 3i. So it's, what is it? Going back to our illustration, V00, V11, V10, V00, V11, V10, and ops.group ID, and intid1 is working mesh dot append triangle, because there's two triangles per quad side. And that one's gonna once again start at V00, but that's gonna go to V01 and then V11. V00, V01, V11. And actually, I think I want to have like top group ID and then bevel, like the slanted slope group ID. Like maybe they have different group IDs. Top group ID, bevel group ID. The group IDs let us do stuff like if we want to further transform this or make selections out of it or whatever, we can do that like by the not bev. We can do that like by group ID. So like for instance, I could select everything with the top group ID and then delete it, and then I would like have one without a top, right? Like you can make sure that you like structure stuff that way. I can also assign like different materials, for instance, to different group IDs, which is probably what I'm gonna end up doing. Like the bevel will just have a different material than the top. Cool. So then for the UVs, the bevel UVs were, so we did we did all the UVs for the top, right? And then we did all the UVs for the top. What was this? As for the top of the bevel, and then for the bottom of the bevel. Yeah, so in UV0 is just going to be n plus it, because the first n UVs were the UVs for the top, so we need to skip past those. And then it's kind of the same logic as for these, except I'm not going to do mod n, because the UVs, like, actually, they don't wrap around. It goes from like UV0 to 1, 1 to 2, and then 2 actually have a third UV, so that like the UV on this face and the UV on this face are different. So that's going to be n plus 1, no mod n, and then this is 0, 0, this is UV1, 0, UV0, 1 is equal to n plus it. And then int UV1, 1 is n plus it plus 1. This is like 90% of procedural geometry is just remembering the pattern of the attribute indexes. It's not as glamorous as you think once you, like, usually you figure out the math, and then the math is like the first 20% of the function, and then the last 80% is just this bookkeeping. Anyway, UV overlay, set triangle to 0. It's the same indices, except instead of V00, it's UV00, UV01. And then for this one, we want to set TID 1, and then it was 00, 01, 11. So I think that's all the faces for the top. We triangulated the top, and then we plotted all those faces. And then we plotted all the sides, right? Where we just did basically a triangle strip around the bevel of the thing. Calculated the normals based on the faces themselves. And then we took that working mesh that we had created and we're appending it into the result. Like, this result might be accumulating several meshes, so we're just sort of squirting it into the accumulator. And this is the part, up until this point, we've just been like working with our own little data. This is the part where we're actually interfacing with the engine. First time chat, Rubio1. Oh hey, how's it going? Is this Looks Engine Ruby, or just someone who has a very similar name? But anyway, I actually changed some structs, so I'm not able to hot recompile my code. So I'm just gonna save my train test scene and then recompile with this new stuff. I had planned to have a more interesting level design stream today, but then yesterday I got sick and I was stuck in bed with a migraine all day. So today we're just doing like the chill stream of all the like boring programming work that I planned to do yesterday. Oops. What's this warning that I got? Warning, log Python, eDeco chunk cap and deco chunk cap have the same name when exposed to Python. Rename one of them. Oh, okay. I guess I should look that up. Anyway. Okay, here we're back. So I'm gonna open up my like geometry script for this island. You can see my like quick and dirty one was to just like take this spline component, convert it to like a polygon, and then like I append it, use their like append polygon, and then I use their flare warp, and then I use compute split normals, and that basically produced kind of what I wanted from this like Unreal tool, or like from this train tool. but like it's not handling convex polygons very well. It's not handling textures very well. So that's why I started writing my own custom plotter. Let's see what happens if I use the custom plotter. So I can delete, or maybe I won't delete all this stuff. I'll just kind of like unhook it. Actually, yeah, no, I haven't actually checked this into version control yet, so I don't want to just go ahead and like delete it all. But we can like just sort of like here. I'm just gonna like do a collapse to nodes and say delete me. Great. So instead, what we're gonna do is we're gonna call the new plot island function. Which, ooh, what is happening here? Why is plot island only taking 2 arguments? Doesn't it have lots of arguments? Oh, right. Okay, so this is just a pure native method. I didn't bind this over to the script. I need to go to my deco, my deco island. Yeah. So here, let me put in like double height, double offset. And then inside of plot island, we'll have, here we'll just, at the top of this file, using namespace, deco util, so I don't have to type that a whole bunch. And then just say f island ops. We'll just leave them all default for now. And then we'll say plot island, target mesh, height. Oop. Oh, right, I didn't copy over the parameters. Sometimes Rider is a little too eager to fix up what you were trying to type. ProcGen Island seems fun. I'm wrestling skeletons. I'm playing the new Astro Polish City. Dude, everybody keeps saying that the new Astro is good. I thought it was just like a generic like test thing. Oh, wait a second. Here, let me change the max cam back to cat cam because the boy has rejoined us. There we go. Hey, little man. Offset ops. Astro's Playroom was really solid and launched with PS5. New one's a whole other game. Nice. I would say maybe I'll download it and play it this weekend, but it's Splatfest this weekend, so my wife is going to colonize the TV basically from the moment she gets home tonight. I think I do actually need to qualify this. Oh, it also needs a shape, of course. So let's say shape. And I think that's taking... Nope, it still doesn't resolve it. Oh well. So now we should be able to rebuild from here. Rebuilding? What's up? Oh, is it running somewhere? Here, let's just shut it down. There we go. Okay, so here we go. Here we've got our in-world spline that's going to define the boundary of the island. And then if we pop in here... Oh, I shut this down without saving anything. What a super smart person I am. Let me do what I did before, where we collapsed. Yeah. Collapse nodes. Let me... And then after we convert the spline to a polygon, this is, by the way, all this is doing is like sampling it at the corners and then flattening it along the z-axis to make like a 2D shape. And then we're plugging that into our new plot. Our new plot island function, which we're going to plot the island into the mesh that is being previewed by this actor. Okay, why is shape... Oh my goodness. Did it think because I said like a reference to a shape? I think I actually need to make this const for Unreal's script binding generator to understand that this is an in parameter and not an out parameter. Okay. Doing a lot of waiting for the engine to open up today. Okay, here we go. So now let's plug the shape into here. And hit go. And it's very unhappy that this is not running first. So let's go again. Okay, let's see what happened. Okay, so it looks like all the faces were plotted, all my triangles were wound the wrong way. Like, we can see it from the bottom, not from the top. Now, the first thing I want to check is basically just that the shape was wound the right way to begin with, so... I'm going to do this in this plot island function. So instead of saying shape, we're going to say in shape. And then we're going to say const auto shape is equal to... I think in my deco function library I had a like fix-up function, like sanity check. Here, let me go look at this. Where was all my shape functions? Sanitize points. Sanitize points would just do stuff like make sure they're wound the right way, and also remove any like collinear points. Okay, it looks like this one is just like a takes a ref parameter. So I need to copy the shape array, and then I sanitize it. So let's do a live recompile. And then here, while that's live recompiling, I'm going to add, I usually have a parameter. This is the thing I wrote earlier that I don't need. But I usually add a Boolean parameter to these like generated meshes called poke, which is just so that I have an easy way to poke them. So did the code compile? The code did not compile. Shape is an undeclared identifier. Oh right, I need to sanitize the shape before I check the number of points. Why do you keep opening Visual Studio? Nobody wants to use Visual Studio. Unreal. You're killing me. This is taking so long to recompile. I just changed like 2 lines. It should only affect this translation unit. There we go. So now if I poke this, okay, they were definitely wound the correct way. So when I guess what happened is, but see, that's interesting. When we triangulated the top, so I guess I have sanitized them the wrong way. I wonder if I just say like algo reverse shape. Okay, yeah, that changes it in place. Because I think when I defined all my polygons, because Unreal's left-handed, I made them all have left-handed order. But this wants them all to be right-handed. Okay, so interestingly... Oh, I see. They're all now inset. So I actually need to do, because I'm winding them the opposite direction, I need to make it that there. It probably makes no sense what I'm saying right now, but... The short version is I wrote all these geometry functions assuming that polygons were wounded left-handed, but geometry script, unlike the rest of Unreal, expects things to be wound right-handed, so I need to negate my offset if I want them to offset out as opposed to offset in. So now when we look at this, we can see the UVs at the top were pretty good. As I scroll this around, they stretch when I increase the bounding box, otherwise I'm just cutting into them. So that's pretty good. The sides, though, everything clearly looks skewed. So I expect it to be aligned roughly to these, with like maybe a diagonal line across the middle, where it's kind of distorted due to like affine texture mapping, kind of like, yeah, this one is like almost looking correct. So like obviously I did something wrong. Basically, when I was plotting the indices for these UVs, like, this math is not correct. So what did I do? Oh, I see what it is. The last UV, I've actually got n UVs on top here, so it should be n plus 1. Call out in the chat if that didn't make sense and you want to understand it. If you didn't understand it but you don't care, don't worry. So if we poke this again... Oop. Poke. Okay, cool. So now we have the UVs the way I kind of expected them to look. So is that they're stretched out. And okay, so it's like, so first things first, all my little like V arrows are pointing down instead of pointing up. So when I plot these, I think I need to flip how I'm plotting the V coordinate. Okay, so now they're at least pointing up. I don't love that like they're not aligned to these grid squares. I think instead of like plotting the U wrapping all the way around, I'm just gonna have each face go from U equals 0 to U equals 1. Polysaurus says this track goes hard. This track is, oh, you can see it here. I just found some like generic Twitch safe music. So this sounds to me like whatchamacallit, a needle drop production music. Have you ever heard that? I don't know if you're allowed to play needle drop music on a Twitch stream. But if you just search like, I think production music, is that, yeah, you can find it on Spotify. This is live stream music, greatest hits, what we're listening to right now. But production music is what I usually like listening to. These are called needle drop because the idea was that like as long as you owned the record and you could drop a needle on it, you had a royalty-free license to use it. So like lots of TV shows use needle drop production music. Like if you ever watch like It's Always Sunny in Philadelphia, that's needle drop music. You often hear it like in menus for a bunch of video games. And like needle drop music is wild because it usually goes way harder than it needs to, because it's basically just studio musicians fucking around. So maybe one day I'll do a test and like just see if like production music is possible. Like, wait, let me see. Let me just do a Google search and see if like KPM production music is safe. Let's say KPM production music okay for Twitch. How to find Twitch approved music. Is this in here? KPM? Okay, I don't know why that came up. KPM Music Library debuts on streaming and download services. What is that? Does that actually work? It's digitized. It's now available to download and stream its entirety. Means every recording in the KPM catalog is available for sync licensing and also for digital music services. Okay, they don't mean like Twitch streaming. They just mean like it's all on Spotify. Okay, I guess I can't just play KPM music. But if you ever just want something which is like stimulating but not distracting, I find like KPM music to be great. Just think of the intro to like It's Always Sunny in Philadelphia. Just imagine listening to that for like 5 hours. Okay, so if I want to have, if we go back to our thing, if I want the UVs to go around like 0, 1, 0, 1, 0, 1, let me think about this. I wonder if I can basically just plot 0, 1, 0, 1, like just have 4 in the overlay. I don't think that actually is going to work. So let's just like go around and we'll say like 0, 1, 0, 1, 0, 1. So here's the UVs for the bevel. So what we're plotting now, and actually I'm just gonna pound if 0 this, so I have the old one that I can fall back on if I want to, else. And then I'm basically just plotting zero, 1, 2 UVs per each side, and then down here it's the same deal. We're just plotting 0, 1. So this changes the way our indexes work, right? We now have 2 times n along the top, as opposed to n plus 1 along the top. Oh yeah, we don't need less than or equal to, we just need less than because we're only plotting n. So UV 0 is going to be n plus it, and then n plus it. Let me think about this. No, this is n plus 2 times it, and then n plus 2 times it plus 1. And then along the bottom, it's going to be n plus 2 times n plus 2 times it plus 2 times it plus 1. The exciting world of remembering indexes. So let's poke this and see. Okay, cool. So now you can see what's happening is we're doing the full, basically the whole UV texture, because I'm using the default texture options right now, which just fully saturates the UV space on each side. You can see that this, because this is like a, you know, it doesn't have parallel sides, there's this kind of weird effect that's going on down the middle here. That's because this is like affine texture mapping. This is like what made textures look weird on the PS1, because the PS1 didn't bother with doing it perspective correct, like is happening right here. It just mapped everything like using barycentric coordinates, and because we basically made a shape which kind of looks foreshortened, even though it's not foreshortened, it exhibits the same artifact, which is that all of these texture maps on the side are going to look like a little funky, right? Like everything in this like upper echelon triangle is going to be parallel to this side, and everything in this lower echelon triangle is going to be parallel to this side. I don't love this effect, but I think the solution is going to kind of suck, right? Because like what I'm going to have to do is subdivide these sides and essentially compensate for how bad this looks, which, like, you know, has the drawback of like I'm not going to have this clean geometry. So and I do want this clean geometry when I generate collision. So I think I'm just going to leave it alone for now, because I've just been triplanar mapping these materials for the moment anyway. But I'll have a note that like I should add a special option to this, like options, like extra options here about whether I want to subdivide the sides. And then if I subdivide the sides, I will only use that as a render mesh and not like feed it in as like a collision mesh. But I think like basically right now we have what is like a perfectly cromulent collision mesh. And you can see I can like duplicate this, and then in principle I could come in here, zoop, 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 and like make another little island, and then we can pull that island down, and we could like insert it on top of this island, zoop, 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 like however we want. And then if I did like a union operation between these two, I could get basically like an island that also has like a height map inside of it. So I wonder if we might like build that into the island itself, or I wonder. But you can see like here, if I go into my event graph here, I was just using 500, 500 as literal values. We can make these into parameters with like promote to variable, call it like bevel height, and then promote this, call this bevel offset. So now if I like look at this dingus, and by the way, you can see if we make this concave, because of the way we're computing the offset now, because it's actually doing it analytically by like offsetting and then remitering the corners, like we can actually make this a concave shape and it has the right slope on the inside here, as opposed to just doing the global flare. That does mean that like as the corners get like closer and closer to being parallel, we're gonna get like wilder and wilder miters, but I don't think that's as much a problem from like my use case, because I'm just not going to be making them that crazy. But you can see we can make the... Actually, let me get in here and say... I had this like cutoff here. Instead, I think what I want to say is offset equals max 0 and offset. No, actually, I'll leave offset alone. And then I'll just say the height max of like height, and like we'll make it never less than like 1 centimeter for now. But we'll wait for that to recompile. Boop, boop, boop. There you go. So you can see we have the like bevel height parameter that can be used to change how tall that bevel is, and then we have the bevel offset parameter if we want to like offset it in or offset it out. And like even when it's offset out crazy like that, Like we can still grab these and pull them in and still get like the offset along this inside seam is still the right distance. And then I think I have collision enabled on this preview mesh. Yeah, so I can just wander around on this, and this will be good for just doing like quick tests of what it's like to have various slips. Let me bring in real quick like a water texture, basically just so we can see. I think my city gym scene has a simple like water plane that I can use. What's going on? Why have we frozen? There we go. So here's this. Oh, that something is glitchy. I think my water plane got Unreal 4 into Unreal 5. I need to revisit this material, but in the meantime, let's go back to the terrain test. Let's paste that in. It's looking quite unhappy. I know I messed with one of these variants and made it okay. Okay, is that, whoop, what happened? All of these have like some kind of like terrible ripple effect. It's all very strange and interesting. Anyway. Not super sure what's going on there. Well, I guess these parameters are overriding what I did in the there we go. Yeah, the seafoam part of that material got messed up. Anyway. Here we go. So now we've got this, like, island plane. Oh, there's no collision on that. Oh, I guess I did collision on, like... Here, let's go back to that city gym. I actually had a plane underneath the water that had the collision. Let's go back to terrain test. And we can paste this in. Move it below the water. Yeah, it's like hidden in game. But yeah, now I should be able to go down here. Yeah, so I'm like colliding with the water. And I come back up here onto the island. Cool beans. So now I can like take this dingus. I can say take the bevel height back down. Or maybe say the bevel offset is twice the height. And then instead of having test UV on this, we can maybe just have like proc grid. Oh, proc grid has something weird that's happening when it's, I guess when it's close to z equals 0. That's like a built-in Unreal thing. That's very strange. But let's just pull the water line up then. There we go. I'm feeling pretty good at this point about that. So now I think the next thing, so one thing that I did, which I don't love actually, is I added this spline component in native code. I don't know if I want to add that in native code. Well, I'll just leave it the way it is. But I do want to potentially add, like here, let's make a new blueprint subtype. Create child blueprint class, and let's call this BP Deco Island with plateau. So in this type of object, it's going to be similar to this. I'm going to change this default. Spline generation panel, rectangle, 1000 by 1000. Now let's make it 2500 by 2500. Good. And then I think maybe this point, yeah, this point is still doubled up. That's annoying. There you go, you're gone. And you need to be select spline point, linear. Cool. So now we've only got 4 points on this by default. Great. I'm going to add a second spline. I'm going to call you the plateau. Basically, take this plateau. Make sure you are a closed loop. Let's select all the points. Make your spline type linear. Move all you guys out into here. And this is basically going to define a plateau shape. So before I do that, so like if I just, so I think like the way that I wrote the generator before, it basically just takes this, it squashes it into 2D, and then it extends this down. So if I called plot island again, this mesh is just going to be squashed down like inside of it, but I actually want it to be on top of it. So I'm going to add a new, I'm just going to save everything, pop out of the engine. I want to add a new parameter to plot island, which is basically going to define like a transform for it. So now let's say f transform ampersand tx. So now when I'm going and adding these positions, I'm just going to be transforming those positions with our incoming transform. Oop, that was 2D. We want to do this. Now we don't need to worry about normals because all the normals are just being calculated based off of these pre-transformed positions. And the UVs are going to be unaffected by this transform, so all that logic stays the same. So I think now I just need to go back to my Deco Island base type. And yeah, actually I think I'm going to go ahead and just, this might be weird. Yeah, I'm going to delete this from here. I think I'm only going to add these splines in Blueprint, because that'll give me more control, maybe? Let me think. No, I think this is fine to add that immediately. I don't know. I'm going back and forth. I'm waffling. Anyway, Then here we're going to add double, like, offset z as another parameter. Or we can just say const f transform dx equals f transform. Here, we'll just call this transform. And we'll pass that in. Where are we going? Are we having problems? Oh, okay, there it goes. Sorry so much the stream is waiting for the engine to start. Okay, nothing's showing up here because, yeah, it's not happy. Here's a cool little Unreal trick. If you have a reference type that needs to be like a struct reference type, and you just want to give it the default value, just right-click on it and say split. This is like as though you were just like making a default value and plugging it in. So now we go back and we can see we've got our correctly plotted island. And now let's look at the new type that we created, the island with a plateau. And the first thing we want to do is override my do rebuild mesh function. And then here, I'm going to wrap this up as like a new function. I'm going to call it spline 2 points. And then the spline, instead of being the specific spline, it's just going to be the input parameter here. And then we're going to add to it the output. It's going to be this array of points. Cool. So now here I can simply say spline 2 points. And I'm actually going to be a little sneaky and make this a pure function, even though it has impure functions inside of it. I can get rid of this now that I know the other one works. Cool. So now we can like copy this into like our new plateau dingus, except we're taking the plateau to the points. And then we are going to take the z location here and just call this like bevel. We'll call this plateau height. We're going to make the plateau. Actually, no, I can just use here. So plateau height will also be plugged into height here, and then promote the variable here. Plateau offset. So now I can bring this out. This is my new island generator, but this one should have a plateau inside of it. Oh, I did not actually call that new function. And look at that, something has gone terribly wrong. What is it? Oh, the plateau height is 0 by default. That's why. And, okay, wait. What's happening here? You drag plateau out as the shape. Why is it? Oh, is it because this is... Oh, I see what's going on. Yeah, these are the points at the top. I actually, in this case, want this boundary to be the base and not the top of it. So let's modify the code to take that as an additional option. So if we go to deco ed util, and then basically in our options here, we should say bool b shape is top. Now we'll say shape is base. I like to, if I have a boolean, make it false by default. So now what we're going to do is, I'm going to say like, so we have our shape here, sanitize and reverse them early out. And then I can say auto base shape equals shape. And then if ops dot shape is base and shape equals deco library inflate points offset otherwise we want to offset the base, right? So in this case, we're like insetting the top or offsetting the base. I could probably make this like a 0 to 1 value, but whatever. I think it's fine the way it is. The other thing I want to do is say ftransform. Here, we'll call this inTransform. And we'll say tx is equal to intx, and if the shape is the base, then we want tx.setLocation to tx.getLocation plus fvector 0, 0 height. So we're just going to add that height in when the bottom is the base. Oh, and then we'll go back to the deco island function. Instead of passing in a raw transform, let's try bool b offset base is true, I guess. Or no, b inset top is false. We want to say ops dot shape is base is b inset top. I think inset top is actually a better word. I should just make that thing. just building? What's happening? Yeah, it's just taking a second. Okay. Okay, there we go. We're opening now. Beep beep boop beep boop beep boop boop beep 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 boop beep boop 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 beep beep boop beep boop boop. Great. So this is now, I think, unhappy again. Yeah, because I changed these arguments. What if I go to deco with plateau? Great, we can get rid of that. We can say we definitely want to inset the top. Okay, cool. So now you can see I can offset these guys down here. And now I'm moving the base rather than the top like I am with this one. And I can basically, like, you know, I can like out drag these to add points, and I can make this have like a different thing. And then I can change the plateau height here. Oh, did I not expose those? Oh, no, they're exposed. Yeah, here we go. Guess I can make it like 100, 100. I think I actually want to express... I actually think instead of... I want, like, maybe the slope to be the same for the plateau and the beaches. So I'm just going to take the, like, get height and then get offset. Not get height, you want bevel height, get bevel offset. And then if I choose a particular plateau height, I can just take like offset over height, multiply by the plateau height. And that should get us an offset for this, which has the same slope. So now if I change the regular offset, you can see both the slopes change to match. I think I like that a little bit better. Or do I? I don't know. But at least, like, now this has the option of, like, expanding out like this. I can, like, match them up, and then they should, like, basically match. So I can actually also default the material on this dingus to be that prop grid dark. So I think this basically matches what I was doing in the world. I think what I don't like is there's that little seam right there. I wish there was a way for me to like snap any of these points that are close to this other one. I think I'm going to write a function to do that. So I think I'm going to like not going to require people to like be super careful. It's just I think like if one of these points is super close to the other one, then I'm going to like snap it to it. Because basically what I'm going to want to do after I plot this second island is they have a thing called apply mesh self union. So let me see if this works. So basically what this should do is it should basically set it up okay, this is not working the way that I like. I think possibly because this one is like a little too high. What if I drop it down 1 centimeter to be inside? Let me just do that as a test. So let's add and then I'm also going to add that other function. Should I start writing that right now? We're really close to lunch. I think I'm just going to get this like self-union working, and then after lunch I'm going to write that function to snap the points of one shape to the boundary of another shape if they're really close. I think what I want to do is just like sync it a little bit into the other one so that the self-union knows to like zip them together. I think it might also be upset that like I don't have a cap on the bottom. I may need to cap off the bottom. I think I can reuse the triangulation on the top, but then just like add n to all the vertices. And I shouldn't need to worry about the texture EVs, but anyway. It is once again unhappy because I added that transform parameter, so you're gonna let me, okay, split struct pin, right. Oh, maybe it's because I was applying that here and not on the plateau version where it belongs. Let's see what happens when I do that. Nope, not get film info. And get in mesh. Okay, something bad has happened. Is it that self-union? Wait, what did I mess up, folks? It appears to not be plotting the mesh inside of there like I would expect. So I called the super method. This was totally just working before I added this stupid part. What is going on? Yeah, of course it's going to start confusing me right before lunch. If I only call the parent method, no, it's still broken. What broke? This is fine. There it is. Okay. Ugh, this is just some like unreal bullshit. Anyway. Inside top. There we go. That's not what I wanted to do. I only wanted to grab. Ah. So now, if this width plateau one, if I apply the self-union, something quite bad happens. I think that's possibly because I have not capped off the bottom. And So that is making the Boolean operation not be happy because this is not manifold. Here, let me go back to like having a separate plateau height and offset. So now I should be able to make the plateau height really tall, the plateau offset go in. Now if I applied self-union to this, is it still messed up? Yeah, it's hella messed up. And here, if I like subtracted like 5 centimeters from the top, it's even more messed up. Okay, so I think I do in fact need to cap off the bottom of these. Let me just do that like really quick and dirty. Deco ed util. So here, oh, we don't need this anymore. So here we plotted the top faces and then we added them on. I think if I go through down here, and I just did n plus on all of these, and I inverted this so that it's facing down. This should plot basically the bottom. And then they'll just reuse the UVs from the top. So this should work. This should plot basically like a bottom cap on the bottom of the island. And I didn't change any header files, so I should be able to just hot reload this. I don't know why hot reload's taking so long today. Usually hot reload is like 2 seconds. My computer must just be unhappy with me for some reason. Okay. So we can come in here and we can poke. Here, let's poke this one first. Poke. And if we look at the bottom, you can see there's now, yeah, there's definitely like a bottom surface. And like, you know, it's all dark because it's facing down, but you know, if we pointed it up, you'd see. So now we should be able to come into this dingus over here, poke it. Yeah, now the Booleans work because it was unhappy that I had non-manifold geometry, but now it has manifold geometry. So what those Booleans did, if I like drag this island over and just look at it in Boolean view, you can basically see what's happened is it has actually subdivided all these triangles and it's gotten rid of all the interior faces. Like I can like do a branch right here. Say promote to variable, apply self union question mark. What do you do? Don't like that. What's happening? Why would it crash when I did that? Okay. Here's the thing about geometry script. Don't use it if you're not a programmer because it crashes all the time. It's got some issues still. It is flagged as experimental for a reason, but because I am trying to generate assets without an artist, I'm exposing myself to this, and oh my goodness, it actually... What is the method that's actually doing it? Apply self-union. Wasn't an issue before, but it is an issue now. Well, this is distressing. How do I open this asset without immediately crashing? Maybe if I early out from my plot island function. so that it just has no vertices, and then self-union has nothing to crash on. Okay. This is distressing. Let's open this and let's just not apply that self-union. So it apparently hates this geometry, even though it was perfectly fine with it a second ago. And then let's open this back up. Just doing a quick recompile. That brings that method back to life. And we can poke this geometry, poke this geometry. So you can see what's basically up is like, here, let me, cause it like really didn't like this when that was not high enough. Let's apply instance changes to blueprint. If this like self-union is really unsafe, I might make a wrapper where I can just disable it, but let me just see real quick. Branch, promote to variable, apply self-union. We're going to make this branch false by default, so we do not run this function by default. Now, over here, you can see there's basically like a single face that's like underneath this, and like maybe that's fine. Like maybe I don't need to do self-unions on these, but like, if it, yeah, okay. It's gonna crash every time now for some reason. Something's gone very wrong in the state of Denmark. Polysaurus says, is it working? Like, this is just game development. It doesn't work until it works. And if you're using hacky stuff, you're going to get hacky results. So let's go back into here and just not bother with this self-union stuff for now. I think it's maybe something about like the fact that these are flush is apparently making the union function not be super happy, I guess. But we'll just ignore that for now. I mean, I guess we could like dip this into that if we really want to resume. But anyway, I think I've got basically like a working version. Like the only thing that I don't like is like maybe I want this sort of like image scene to like be better, or maybe not. I don't know. And I think there's like maybe a way that I can make that work, but for the moment we've got all these. We can now basically do an island. An island can have a plateau. I don't know if an island's going to want to have multiple plateaus, or if there's like maybe a better way that I can generate like a fillet in between here and here, where instead of having a sharp edge, here, let me see. Like maybe, like instead of having a sharp edge, the plateau can have like something like a smooth step from the bottom to the top. Since I'm like generating these now myself, I can probably add that as an option. Should probably make sense. Like maybe there's an option to round off the bottom and or round off the top. And like maybe I round off the tops on this one and I round off the bottom and the top of this one. But at least for what I'm trying to do, which I can open up my like main city gym and show you what this has all been towards. Like I've got this main island here which has like a pretty big shape, and then it's got this raised section in the middle underneath this space elevator. So I want to replace this like mesh that I just authored in Blender with my new tool so that I can like very carefully control the whatchamacallit, like the coastline and the shape of this height in the middle. And then I, instead of having to like hand model this tunnel and like these side tunnels, I can just use the fact that tunnels can cut their way through other meshes to cut into the meshes that are generated by the island tool for all of this like underwater like sewer stuff. And then yeah, I'm probably also going to make a very simple like chamber generator, which just, I mean, this is basically just a chamfered cylinder, so that should be easy to write. And then yeah, I can just use my tunnel tool for all these connecting tunnels. I can use the like chamber tool for making these 2 chambers and any more chambers, because I think I'm going to have a more elaborate sewer system. And then yeah, I can change the shape of this island so that it like matches the buildings better and like bulges in some places where I want better, and also I can more easily control this. This is the only way I was thinking that like maybe I wanted them to be smooth like in terms of their slope. It's just because like maybe I want like this slope like going up to the top like to be flush, but like maybe there's other ways to get that to work. And I don't necessarily want it to be flush on both sides. And possibly I want to have like multiple raised or lowered sections, so that's like another thing that I need to think about. Another reason why I kind of want the booleans to work is if I could take one of these like island tool sections and like invert it so it has a negative slope and then dip it down and then use the boolean subtract to basically like maybe be able to subtract like a divot right here so that like this area inside of here is actually a little bit like below ground level. And then I think I also need to, I just hand modeled this like water plane that like cuts out the like main terrain. I also need to do a thing which is like generate a disk and then subtract all the main islands from it. That way when we go into these tunnels there will be like a water line inside of here. So it's like making sure to cut it out as well. Or maybe I just use the tunnel tool and I just also cut the tunnels out of the water line. So anyway, thanks for watching. This is just watching me code my little island tool. Here I'll just go back to my train test scene just to show. So, you know, what we did was we added these splines to the scene. We convert the splines into 2D shapes, and then I basically inflate or inset the 2D shapes so that I can have a consistent width bevel no matter what the shape is. And then I just did some like basic stuff to like triangulate the top and do a triangle strip along the sides, and then also, as we noted, generally made some like more sane UVs than what was being generated by the default geometry script tools. And we noted that like there's this like annoying affine artifact on the side, which I think I'm going to fix by just increasing the resolution of this as a like render mesh, but since I'm mostly thinking about this as a collision mesh right now, I'm not too worried about that. So I try and do the stream every Friday. I'm certainly, it's going to get more interesting once we're actually in early access, but I do want to like make sure that like I get into the habit of doing it before like the game has a much bigger audience. So thanks for watching. I'm gonna go get lunch now. And yeah, I think I'm behind like 3 or 4 putting these on the YouTube archive, but probably this weekend I'll get those back up to date. And I think I'm also going to start just like posting little clips more often to YouTube, because I've been relying on Twitter a lot, but I think Twitter kind of sucks now. I kind of want to start shifting stuff over to Blue Sky. Blue Sky keeps promising video, but they haven't actually put video in yet, so I've seen a lot of other people basically posting YouTube shorts and then doing embedded links to the YouTube shorts on Blue Sky, so I think that might be my new process. I'll still post on Twitter, I just don't want it to be my like main avenue, because you know, it's run by like a little petite tyrant who everyone sucks. That's so. Ooh. Anyway, cool. Bye. Okay, so what I was planning on doing in the start of the stream, actually, let me get some music going. I'm gonna do a like quick test here and see what happens if I try playing some KPM music, if it gets like flagged by Twitch or not. So here, just gonna like update my label here. Experimenting with KPM music. So I was talking about this earlier, but this is basically like needle drop production music. They're just really nice to listen to while you work. I mean, if you've like watched any TV show that cheaped out on the score, they were almost certainly using this production music. I thought it would be cool if I could just play it instead of lo-fi beats, but I don't know if it's going to be tagged as like copyright music when I try and do the VOD. So I'm just playing this one track, Screw Loose, right now to see what happens. If this gets tagged when I put it on VOD, then I will never try this experiment again. This is what I listen to when I'm not on stream. So it'd be nice if I could harmonize that. Okay. Experiment over. Change the title back. Coding and hanging out. So let's see. Free Twitch safe music. What's something we've never played before? It's this one. This one looks like it's a pretty long list. Let's try it. It's Curly and Game Chops. Okay, let's figure out. Did I close Rider while I wasn't looking? I guess so. Okay, so first thing I want to do is I'm going to write a function. So I've got these like islands that I can draw. Here, let me see if I can bring up like a drawing program. Zoop. So like I've got these islands where you can draw a shape, right? And then it creates an island in that shape, and then you can draw a plateau shape inside of it, right? and then I want it to basically be like generate a beach here and generate like nice little slopes around this, right? But what I want to do is like if I drag one of these vertices of this like plateau like off the island, I just want to like clamp it to the island. My stabilization setting is way too high. There we go. So like basically I want to say like given a point and given a shape, if you're inside the shape, leave the point alone, but if you're outside the shape, project it to like the closest point on the boundary of the shape. And it's a little more complicated than normal because like these shapes can be concave, which basically just means it has any bits, right? So there could exist 2 points where the line between them leaves the shape and re-enters the shape. So the way that we handle this, and here, let me just like grab a different color. So here's the shape. To know if you're like inside the shape, like if I've got some point here, then like essentially what we want to do is like cast a ray and count the number of times it touches the boundary. And if that number is odd, then you're inside the shape, right? So you could imagine like I'm right here and I cast a ray this way, it hits the boundary 1, 2, 3 times. That's an odd number, so it's inside. Meanwhile, like I might be like out here and I cast a ray 1, 2, it hits it an even number of times, so that point is outside the shape. So that's what we're gonna do. We're basically just gonna say like, hey, if you're inside the shape, leave it alone, like I said, and if you're outside the shape, we're just gonna find the closest point on each of these line segments, and you know, zoop, and like 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 whichever one you're closest to, which in this case would be this one, that's your like closest point on the boundary. And I noticed I'm still just talking into dead air because nobody's joined the chat yet, but it's good to have an introduction just for the archive. Let's go to my deco ed util file. We're going to say effector 2D clamp to shape const effector 2D ampersand in position const t array of effector 2D ampersand inch. So the first thing I'm going to do is like an early out if InShape.num is less than 3. This is going to return the position. That's a weird case. Let's not worry about it. So first thing we're going to do is compute the min and the max of the shape. Make a quick alias for the number of input points. So min is min of min and in shape it.x. Max equals fmap max of max and in shape it.x. So basically, I just like, actually, let's get the min and the max in both directions. So f factor 2d min, f factor 2d max. Then I think I use, yeah. And then basically I can get the diagonal distance is max minus min dot size. And this is basically just going to be the length of the ray that we cast. We know that it's like longer than any side. We can also know really quickly, by the way, like const bool be in range is if we're like inside that bounding box or not, right? If we're outside that bounding box, then we just already know we're not in range, and we can early out in that case. So if, you know, in position.x is greater than or equal to min.x, and here I'll split this out over multiple lines, in position.x is less than or equal to max.x, and in position.y is greater than or equal to min.y, and in position.y is less than or equal to max.y. So if we are B in range, here, we'll just call this B inside. If B inside, then let's further check if we're actually inside the shape and not just in the bounding box by casting array and counting the number of times it hits the boundary. Odd equals inside, even equals outside. Okay. We have to do this more expensive test because the shape might be concave. So for it is 0, it's less than n, plus it. 1 is it plus 1 mod n. So vector 2d position 0 is in shape 0, const vector 2d position 1 equals in shape, oh, I mean not 0, it. It's it 1. So these are just the two corners of one of the line segments on the shape. And we do this mod n bit right here to wrap around. So when we go from the last point, we connect it to the first point to make it into a loop. So now what we need to do is say like, here, let's get the endpoints of the array. Array 0 is just going to be our in position. And array 1 is going to be our in position plus f vector 2d. And I'll just do diagonal length, diagonal length. This is like way too long, but it's like good enough for government work. It's like definitely longer than like the longest chord across, so we should be guaranteed to get all the hits that we need with a ray that's long. So I do have this, that's a line-line intersection. Yeah, I do have this vec util line-line intersection. So what we're going to do is, yeah, our A0 is ray 0, our A1 is ray 1, our B0 is position 0, our B1 is position 1, and then I need to have, yeah, double out ray T, comma, out shape T. And what we really care about is if out shape T is less than or equal, is greater than or equal to 0, and out shape T is less than or equal to 1. Yeah. We'll say int hit count 0, right, add hit count. Actually, another way that we can do this is to simply set the inside to false. And then every time we find a hit on the boundary, we set the inside to not be inside. So this means that, like, if we hit it an odd number of times, be inside will end up true, and if we hit it an even number of times, be inside will end up false. So that refines our be inside. So when we're down here, if we are still inside, we can just return the in position, we're done. Otherwise, we need to find the closest point on all the sides. So let me see. For line-line intersection, I think I have an alternate version of this. No, actually I don't want line-line intersection. I want the distance from a point to a line. So I don't know if I have a function for that. Let me just write one. So what we're going to do is we're going to get the offset from A is in position minus A. We're going to get the offset AB is B minus A. Oh. Then basically we want to take the, oh wait, these are vectors. So F vector 2D distance from A to B, so the offset AB.size. Say if distance AB is less than a super small number, just return the distance from in position to A. This is the like weirdo case where both A and B are the same. I think actually, is my music like way too loud? I don't know, I'm looking at the levels. I always get super paranoid about this stuff. I'm gonna take it down a little. But if they're not the same, then we can compute vector 2D dir AB, which is just offset from AB divided by the distance from A to B. And then we can get distance along dir AB is equal to in position minus A. You don't actually need to save this. Dotted with dir AB. And then we want to return vector 2D, the distance from in position to fmath lerp from A, where we want A plus fmath clamp distance along AB, clamp this from 0 to dist AB times dir AB. There we go. This may be a faster way to write this function, I don't know, but this makes sense. Right, just to sort of like draw a picture of how that works. You know, we've got a line with points A and point B. We've got some position in position, right? And we basically get this vector, the dot product, that little like bar over here, that projects it onto like a distance this way, right? And then we basically are clamping that distance from 0 to this and then getting the distance from this point to this, you know. Or if like P was over here, the distance would be this one, but we would clamp it to here and then we would get the distance to here. So we're getting like a segment distance. So let's just say double min. Let's just say the min distance is equal to distance to segment of the in position to in shape 0, in shape 1. Then we want to say in it equals 1, it is less than n plus it. Actually, I think what we want to do is we don't just want this distance, we also want what that position is. So we'll call that out position. Then we'll say out position is equal to that. So here we're going to say f vector 2D result. That's weird, my keyboard wasn't responding for a second. We're going to compute the distance from there to the first segment. Actually, I'm going to do from 0 to n minus 1. And that way in this I can go, yeah, like candidate double candidate distance equals distance to segment in position in shape it minus 1 in shape it. Like I don't need to do this modulo step that I had to do up here because I already basically did that when I calculated the initial value. And we say if candidate distance is less than min distance, we're basically finding the distance to all the segments, and then if we find one that's better than our sort of current result, then we just set it to that candidate. And then yeah, the end of this function return the result. This could be constant. I don't know why I care so much, but I usually try and keep that all in. So that is clamp to shape. So I think what I want to do now is as an optional parameter to plot island. No, not as an optional parameter to plot island. I think I'm just going to make this like a deco island helper function, which I'll just say blueprint pure t-array of f-vector 2D clamp shape to shape. And the inputs are in boundary, or we'll call this in outer shape, and then we'll have const t array f-vector 2D. In my coding convention, I don't put spaces in type names. Ampersand in inner shape. Actually, I don't think I need in. This is a const function. So, basically what we want to do is say t-array f-vector 2D result set num uninitialized to inner shape dot num. We'll just get that, pull that out into a variable, then we'll do a loop. And we'll say result it is equal to deco ed util clamp to shape, and then it says inner shape it comma outer shape. So we're just going to go through all the corners of the inner shape, clamp them to the outer shape. That's our result, and then we return that result. Cool. So let's pop this open. Is anyone in the chat? Anyone actually watching? No one's watching. I wonder if Friday afternoon's just like not a great time to be doing programming streams. What have we got going on? Oh, did I not match this declaration internally in the header file? I did not. Wait. What did I do? I should not have outpause here. It's not an outpause. It was this one, distance to segment. Ugh, confusing myself by not thinking. Yeah, these things go back to the way it was. This was right. Cool. Let's crack it open, hook that function into our blueprint and see if it works. This is either going to work and I'm going to go, yay, it works, or it's going to break in some hilarious way, and then we can all have a good chuckle about how bad the program looks. Ooh. Okay, so you see, here's our island where we have the outer shape and we have the inner shape, and we want to basically constrain it such that when I drag this value out here, it gets constrained to the inner shape instead of like overhanging the ledge like this. So we'll open this up, and basically what we want to say is we have our spline component, which is the outer shape. We have our plateau, which is the inner shape. And then, what did I call it? Clamp shape to shape. There's the outer shape. There's the inner shape. There's the clamped shape. Doop. And now you see, it's working great. So like, if I move this point like outside the range, this one is guaranteed to stay inside the range. Or not. Look at that. We're totally busted somehow. So I am inside, but it is still clamping it to the outside because it thinks that I'm outside for some reason. Let me check. Let's first just try and reason through the code and see if I made a typo before debugging the code. So first, to check, we get the min and the max. So here's the min, here's the max for the shape. And then we say if x is greater than or equal to min, if x is less than or equal to max, if y is greater than or equal to min, and y is less than or equal to max, then you're inside the bounding box of the shape. And min is computed correctly, max is computed correctly. That's all good. Then if we're inside the bounding box, we turn this to false because we want to count the number of times we like hit the outside. So position 0 is in shape it, position 1 is in shape it1, which is it plus 1 mod n. So then we are computing from ray 0, which is position to position plus some diagonal length. Let's just multiply this by 999 and see what happens. Maybe for some reason that was supposed to be long enough, but maybe it's not long enough. Nope, that was not the bug. Let me just check that this is true. Like all these points are snapping to the end, right? Yeah. Yeah, that one's snapping over there, and it gets even worse when I bring it over there. So, line-line intersection. This basically gives me out A, out B for like position 1, position 2, position 1, position 2. I don't need this 999 anymore. But from ray 0 to ray 1, position 0 to position 1, out ray T, out shape T. And if the shape T is greater than or equal to 0 and less than or equal to 1, that means that it has intersected Wait, let me think about this. Maybe I need to say like out ray T is greater than or equal to 0 and out ray T is less than or equal to 1, and like I need to check both of these just for crazy person's sake. I'm going to make sure that those are all double literals. So let's grab this. Hey, now we're working. Okay, that was what we needed. Excellent. Yeah, I guess it was casting like the ray like infinitely and getting hits that was behind it. So now you see when the plateau shape is completely contained inside the island, it's fine. But if I try and drag any of these off the island, then they're just going to be clamped to the end, which will be pretty useful if I want to like have part of this extend like all the way to the end, like in some cases for some reason. So, and then I still have the ability to like alt drag if I need to like make these other shapes. So cool. And then I think I had this, yeah, I adjusted it to take the height, but another way to do it was like this. This was offset. Oh, this should be plugged into offset, and this should be plugged into height. And this ensures now that actually the slopes actually match as well, right? Wait, what am I controlling? I'm controlling the offset. Actually, I want to control the height. Yeah. So with this one, I can now, like, all I need to do is adjust the plateau height. Where is that? Here we go. And you can see the it's auto adjusting the offset amount so that the slope matches. And if I like were to look at this with all the splines turned off, this is like a nice sort of like flush shape. I'm pretty sure even if I don't union them together, like PhysX is relatively okay, that it's not gonna like mess me up crossing that seam. Yeah, cool. Okay, so I think I have almost everything I need to start replacing my terrain in my city level. I think the last thing I need to do is basically update this. Okay, actually this was something I started to look at like before, which was the option to do a self union. My R key is once again not working. I think my keyboard is just failing. Promote to variable. We'll say apply self union. What was happening before was that I was getting a crash because I think, see what's happening if you look at this in wireframe, like these two surfaces, right? The top surface and the bottom surface are like perfectly flush with each other. And I think that was like making geometry scripts, like implementation of constructed solid geometry, like really unhappy. So I'm going to turn this off by default, just in case it crashes, so I don't get into like a crashing loop trying to turn stuff back on. And then we're going to say git enmesh self union. And then I'm going to turn off all the special options. For now, I'm just going to apply self-union. Yeah, these default values kind of suck. Let me apply instance changes to blueprint. Cool. So now I apply self-union. Yeah, we're still crashing. So something's still unfortunate here. Let's actually like debug this. Let's go through the source code for geometry script and see how far we're going. So we call do rebuild mesh, edit mesh internal. Yeah, so it's f mesh self cut, I guess, is the method for doing like a self union. So then there's cut, so it's going to add intersection segments, insert edge vertices. This method is going to split an edge, and it's calling, what is this? A change timestamps, which is calling out to on split edge set element from lerp. And in this case, the lerp value seems relatively correct. Now, what type of element are we setting here? This is on like one of the mesh overlays. It's a very suspicious number there, 65,532. So this triangle 0 is -1. So split info. Where's that -1 coming from? Index base A is base triangle 1, index of base A. Original vertices. Oh, some of this code has been optimized, so I can't see all the values. Because it's been reusing some of these storage slots when it fixed up the code. But yeah, there's like a bug in this code where this base A, original vertices dot A, A is 0, then index of 0 was returning -1, and then when it tried to use that index in this triangle array, we got just a total junk value. That's very curious. I wonder... Here, let's stop debugging, shut down the process, start it up again. I wonder if something about the way I'm plotting the mesh, like maybe like the way I'm handling UVs or something, is producing like geometry that's a little incorrect for some reason. So let's just see if, like, before I apply self-union, I think there's like a repair. Compacts to remove any holes. Maybe if I compact it first? Seems like this isn't going to matter. Let's try clicking that terrible button again. Yeah, we still crashed. and we're still crashing in the exact same place. So it's quite frustrating that geometry script isn't bounds checking these indices. Let me see if I actually, let's just do like a really dumb thing. And when I generate my mesh, I'm not going to generate normals or UVs for it. This file. Let me just see if it's a problem with the attributes. So I can basically just F0 this out. For the UVs, we can F0 this out. Then I'll just comment out all these overlay calls. I'll comment out calc normals. So there should be no attributes on this mesh. It should just be vertex positions. So it'll look shaded wrong. But if my assumption is correct and the way that I'm passing element data into the mesh is like actually bad, then this will prevent it from crashing. So we can already see like the normals and the UVs are bad. So this just looks like a black blob. But at least now I can click this button and we don't crash. Okay, so I think there's actually something bad in the way that I guess that I'm passing in those UVs. So let's now come back here. First of all, let's see if it's the normals that are the problem. So I'm going to call calc normals again. Recompile my code. Oh, geez, I just realized I had that on my completely other screen. People weren't seeing it. Ooh, sorry about that. So I can grab this actor, I can poke it. Now it has normals. When I apply self-union, it appears to be fine. And if we look in wireframe, we see the union actually succeeded. There's no longer like an interior face underneath the bottom there. This is like now just like nice manifold geometry. So it appears that the solution is to look into how I'm applying these UVs. Because apparently it doesn't like what I'm doing with those UVs. I think that's what's causing it to crash. So there's got to be a bug in my UV plotting code. Like I can come back into here. I can pick this dingus. I can turn self-union off. And then if I turn this like UV code back on, I don't know why this would be the case, but now we're going to say first, when I click this, it should crash. Yeah. So there's definitely a bug in the way that I'm plotting UVs. Maybe one of those indexes is bad and goes out of range. I don't think that's going to be very fun to broadcast, so I'm just going to head off stream and just be doing that for a while. But I'm just going to like append this to the last thing that I did, just so people get like a little bit more extra juice out of a little extra geometry. I thought that was like an interesting problem to like inset one shape within another shape. So thanks for watching. Bye.